Welcome to my first attempt at flipping a math lesson. This is Jeff Silman, 5th grade teacher at Glendale Elementary, and we are going to try to flip a math lesson. So these are the things you will need at home. You'll need access to Schoology or the internet or both. You can access this through a computer, a Chromebook, iPad, cell phone. Make sure you have paper, pencil ready. You need time at home to watch the videos. And the good thing about flipping your math lesson is that you can watch the videos a couple different times. If you don't get it the first time, you can rewind it and play it again. Write down any questions that you have, bring them to school the next day, and thank you for having the courage to try something new. So let's get going. Unit 8, we are starting Unit 8. It's all about algebra, functions, and graphs. Algebra is just really a mathematical language that uses its own notation. So we're going to apply this language to show relationships between two quantities. So we are looking at different equations, functions, and graphs. And here's some examples. This is something you might learn back in high school, but these are the types of equations you will have access to starting once you get to middle school and high school. Functions are tools that really help us take a look at real world models. Like how fast things go or how temperature goes up and down. Graphs, we can graph out the relationships between quantities. So these are the types of problems by the end of Unit 8 you will understand and be able to solve, and you will just love these types of problems. Okay. So one is the simplified form of the expression 4 to the third power times 12. Another one might be finding the value of n. Solving word problems, finding the correct equation for this function table, graphing out the correct graph. And algebra is kind of fun. Think of it like a puzzle that involves figuring out the missing pieces and how they fit in to solve a mystery. Okay, so there's two different parts to this lesson. The first one's on exponents and expressions, and so we're going to go through the first activity. We're going to learn how to use exponents and simplify expressions and to solve equations. If at any time I go too fast, feel free to pause it, rewind it, and listen again. Okay, here we go. Is there an easier way to write the following expression? So we have 4 times 4 times 4 times 4 times 4. Is there an easier way to write that? How about an easier way to write 6 times 6 times 6 times 6? Well, there is. It's called using exponents. A short way to write the expression 6 times 6 times 6 times 6 is 6 to the 4th power. Why the 4th power? Because we have 1, 2, 3, 4 sixes. You read this as 6 to the 4th power. This 6 is the base, or it's the repeated factor or number. The 4 is the exponent. When you represent a number with a base and an exponent, you are using exponential form. The words highlighted in yellow are words that you will need to know throughout this whole lesson. Okay, so let's practice. Take a minute, take 30 seconds, and write down on your piece of paper at home, write down what you think these 7s will be in exponential form. Okay, go ahead and pause your video. Good, welcome back. Hopefully you had 7 to the 2nd power, 7 to the 3rd power, 7 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7 to the 10th power. Okay, here's some things you need to know. Whoop. Geometry connects the exponents. Okay, so 7 times 7 is 7 to the 2nd power and can be said as 7 squared. 7 times 7 times 7 is 7 to the 3rd power, or 7 cubed. Okay, good things to know. Also, we talk about exponents in a certain way. For instance, 7 times 7, 3, 4, 5, 6, 7, 8, 9, 10. 7 to the 10th power and can be said as 7 to the 10th power. This is the way it's written out in words. Okay, so at home, I want you to pause your video. I want you to try these 6 problems and see what you get. Welcome back. Let's check your answers. We have 3 to the 10th power. 4 cubed is 4 to the 3rd power. 8 squared, 8 to the 2nd power. 5 to the 5th power. Now this one's tricky. We have 1, 2, 4. It's 4 to the 2nd power times 3 to the 4th power. 1, 2, 3, 4. 5 to the 3rd power. 1, 2, 3 times 2. If 2 is by itself, you can just write you don't have to put 2 to the 1st power. You can just put 2 down. Okay? So now we're going to go the other way. We're going to try to solve these. Okay? So try this. Go ahead on your piece of paper, try solving these 6 problems. Pause it right now and see what you come up with. Welcome back. Let's check your answers. Hopefully you had a chance to work these out. Ready? 2 to the 3rd power is 2 times 2 times 2 times 5, which equals 40. 12 to the 2nd power is 12 times 2. Sorry, 12 times 12, which is 144. 10 to the 4th power times 2. So 10 times 10 times 10 times 10 times 2 is 20,000. 1 to the 3rd power, 1 times 1 times 1 times 4 to the 2nd is 16. We have 5 to the 2nd power times 4. And then 3 to the 2nd power is 3 times 3 times 2 times 2. Okay, let's keep going. What if the exponent is a variable? Here are some examples of that. Okay, we can keep trying to find what n is. Okay, so 3 to the nth power equals 27. Okay, so take some time, pause your video, take some time right now, solve these 6 problems, and on the other side of the pause, we will take a look at these. Welcome back. Let's check your answers. We have n to the 3rd power. So 3 to the 3rd power is 27. 3 times 3 is 9. 9 times 3 is 27. N to the 4th power, n is 2. 2 times 2 times 2 times 2 is 16. 7n is 7 to the 2nd power. 7 times 7 is 49. And so on and so on. Okay, let's keep going. A square number is one in which a factor is multiplied by the same factor to get the product. 3 times 3 is 9. 4 times 4 is 16. 3 to the 2nd power is 9. 4 to the 2nd power is 16. Square numbers can be represented by drawings of perfect squares. For instance, they want you to do this. They want you to find 8 times 8. 8 squared is 8 times 8. They want you to draw a picture that looks something like that. Okay, go ahead and pause the video, solve these 19, 20, 21, and make a drawing. Go ahead and pause your video now. Thank you. Welcome back. We have, let's see if sorry, right there. Let's draw some more squares. Here we go. Basically, all this is they want 8 going down, 8 across. This number right here, when you multiply 8 times 8, you get 64. 12 times 12 is 144. 11 times 11 is 121. It makes a perfect square if you multiply it out. Okay? Square roots. Square roots asks us to find the base of an exponential expression. Okay? So the square root of 9 is 3, which relates to 3 squared equals 9. The square root of 16 equals 4, which relates to 4 squared equals 16. Okay? So again, pause your video, find the square root of 16, the square root of 64, and the square root of 81. Make a drawing if that helps you. Pause your video now. Welcome back. Let's check your answers. Square root of 16 is 4 because 4 times 4 is 16. Square root of 64 is 8 because 8 times 8 is 64. Square root of 81 is 9 because 9 times 9 is 81. Okay? Now, the second part of this lesson talks with prime factorization. Okay? So we're going to learn about and demonstrate the ability to find prime factorization of composite numbers. Okay? So you can do this part at home if you want. Otherwise, we're going to kind of talk through it as we go through the lesson here. So let's find all the factors of these numbers here. Now, a factor are numbers that go into a larger number. Okay, so pause your video, see what you come up with, and then unpause when you're ready. All right, so factors of 12 are 1, 2, 3, 4, 6, and 12 because 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Factors of 30. 1, 2, 3, 5, 6, 10, 15, 30. 1 and 30 are factors. 2 and 15 are factors. 3 and 10 are factors. 5 and 6 are factors. Circle the common factors. So 1, 2, 3, and 6 are common between 12 and 30. Okay? If you look at 26, 1, 3, 5, and 15 are factors of 15. 1, 2, 4, 5, 10, and 20 are for 20. 1, 2, 4, 5, 8, 10, 20, 40 are factors of 40. And if you circle the common factors, it's just 1 and 5. Okay, now they're looking for multiples. So multiples are if you count by 3s and you count by 5s, are there common multiples? Okay, go ahead and pause your video and try these two problems. Okay, let's come back. Here are your answers. If we count by 3s, we have 3, 6, 9, 12, 15, 18. If we count by 5s, we have 5, 10, 15, 20, 25, 30. The commonalities are the 15s. We circled that. Okay? If we count by 4s, 4, 8, 12, 16, 20, 24. We count by 8s, 8, 16, 24, 32, 40, 42. Again, these are all multiples of 8s. This is a multiple of 12. If we count by 12s, 12, 24, 36, 48, 60, 72. Okay, you can try these at home. Factors of prime numbers. Now, what's a prime number? Think about it in your head. Think about what a composite number is. Think about back through all your schooling. Okay, a prime number is a whole number that has exactly two factors, 1 and itself. Like the number 5. The only two numbers in the entire world that goes into 5 are 1 and 5. Okay, the same can be said with 7. Only 1 and 7 go into 7. A composite number has more than two factors. The number 4, we have 1, 2, and 4 that go into 4. The number 10, we have 1, 2, 5, and 10 that go into 10. Okay, so here's some practice for you. Write the words prime or composite on these 6 problems. Remember, prime is only, well, you can go back to the definition. I'll let you figure it out. Ready? Pause your video. Okay, welcome back. Let's check your answers. 29 is prime because only 1 and 29 go into that problem. 56 is composite because there are many numbers that go into 56. Same with 60. Same with 99. 83 is prime because only 1 and 83 go into 83. And 48 is composite. And here's a secret. If you look at 56, 60, and 48, they are all even numbers. So even numbers are composites because 2 goes into an even number. There's a little secret for you. Okay. All composite numbers can be written as a product of prime numbers. So we're going to use some